In this video, we first present an overview of the Explainable Mapper workspace, followed by demonstrations of two use cases. This interface visualizes word embedding data from the final layer of the BERT model, fine-tuned on the SuperSense role classification task. The center is the mapper graph of word embeddings. It supports basic interactions like zooming, panning, and dragging. This view shows the 2D projection of the word embeddings. Users can switch different projection methods and select regions of interest by using tools like lasso or brush. Once a region is selected, the corresponding regions in the mapper graph are highlighted. At the bottom is the settings panel, which colors views by SuperSense labels or by L2 norm. Mapper node size can reflect the number of instances or be set equally. Similarly, edge width can encode overlapping instances or be set equally. Users can overlay keywords onto mapper components, which are pre-computed by GPT. These keywords are positioned to avoid overlap, and additional keywords appear upon zooming in. Keyword overlays can also be applied at the node level. The mapper graph layout can be set to a force-directed layout or aligned with the projection view. Users can use explanation and perturbation agents by selecting different graph elements. Selecting a node reveals a bar chart showing the distribution of tokens or labels within the node, along with LLM-generated explanations, consistency scores, and perturbed explanations. A detailed list of instances appears in the table below. A comparison button allows users to select a second node to generate comparison explanation and show detailed information. Under the edge selection mode, users can select an edge to inspect and explain the relationship between connected nodes. Users can also select the shortest path between two nodes to generate a path evolution explanation. Clicking on individual nodes along the path reveals example instance. Under the component selection mode, users can select a component to inspect its explanation and inspect individual examples. Besides, in the control view, users can adjust mapper graph parameters to generate a new graph, or switch to the ball mapper setting to create a ball mapper. Now we show the first use case, temporal prepositions. In the final layer of the fine-tuned BERT model, we observe that temporal prepositions are contextualized such that words indicating end time, like until, and start time, like from, are largely separated into two distinct components. We then compare the two components and generate a comparison explanation with a high consistency score. It says one component primarily uses since and from to denote starting points, while the other uses until and to emphasize endpoints. Additionally, we observe a single node labeled as end time that is separated from the main end time component. To investigate this separation, we select one node from each component and choose a representative sentence from each to construct a perturbation trajectory connecting them. These sentences are projected onto the mapper graph, revealing that the transition between the two components occurs between "I waited until 5 p.m. and then departed," and "I thought I would have to wait until 5 p.m. By comparing other sentences, this may indicate that word position influences this separation. We show the second use case, since in temporal and causal contexts. The word since can convey temporal information or causality. In the early layer, by searching for the word, instances of since with different labels are mixed within a single component. By the final layer, they split into three components, each matching a specific label. In the middle layer, they form a continuous path, with labels gradually transitioning from one type to another. To explore the evolution, we apply Path Explainer to this path. The explanation consistently suggests that the usage of since evolves from explaining reasons in early nodes to denotes time in the later nodes. To further analyze this transition, we create a trajectory between the two end nodes of the path. In particular, we notice that from the sentence, "Since I wanted a better one," to "I have since traded my old car," the meaning of since shifts from causal to temporal. The corresponding attachment positions also transition from a mixed mapper node to one with purely temporal labels, supporting the path evolution hypothesis. Thanks for listening. Please refer to our paper for more details.